Good morning, students. So myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about some more examples in the magnetostatics. That is in the 4th unit. The last 2 classes, we did some examples or 10 examples, the magnetostatics. Now, in this, given that the general vector A bar is H bar is equal to A theta bar coefficient given and A phi bar coefficient is given. In spherical coordinates, find the curl of H bar at 2 pi by 6 and the 0. What is the 2 there? 2 is the value of R and pi by 6 is the value of theta and 0 is the value of the phi. And A theta bar coefficient is a 2.5 and A phi bar coefficient is a 5. So del cross H bar, it is a AR bar coefficient, A phi bar coefficient and the A theta bar coefficients. So del means AR bar, A theta bar and A phi bar. So since it is a spherical coordinate system, you see, after applying the del function, 1 by R sine theta, dou by sine theta H phi by dou phi, not the dou phi, dou theta, minus dou H theta by dou phi, plus 1 by R. This is a formula we have, del cross H bar in the spherical coordinate system. In the last class also we see that the del cross H bar in the cylindrical coordinate system. In this, the given function H bar is equal to A theta bar. HR coefficient is a 0. H theta is a 2.5 and H phi is equal to 5. Substitute these values and at the point of 2 pi by 6 and the 0, find the curl function of H bar. So 1 by R sine theta, dou by dou theta of H phi. What is a H phi? Is a 5 sine theta. 5 into sine theta. And what is a H phi is equal to, H theta is equal to 2.5 dou phi into AR bar plus 1 by R into, there is no any HR coefficient. HR coefficient is a 0, the term is a 0, minus dou R value is R into H phi. H phi value is a 5. 5R, dou by R into A phi, A theta bar. And the last term, it is a 1 by R into dou R H theta is 2.5 by dou R minus a 0. What is a minus 0? HR is equal to 0 into A phi. And 1 by R sine theta, with respect to the theta, we are applying for the sine theta derivative is a cos theta, phi cos theta, minus, there is no any phi term, the term is a 0. Similarly, 1 by R into, the term is a 0, the second term is a R dou by dou R is a 5, minus 5, and the 2.5, here also the R with respect to the 2.5. Then, cos theta by sine theta here, cos theta by sine theta is a cos theta, 5 by R AR bar, minus 5 by R A theta bar, and 2.5 by R A phi bar. Substitute the value, R is equal to 2, theta is equal to pi by 6, and phi is equal to 0 degrees. The del cross H bar is equal to 4.33 AR bar minus 2.5 A theta bar plus 1.25 into A phi. What it matters to simple. If you know the formula, substitute the values, apply the derivative, and then find the value of del cross H bar. Coming to the next example. Prove that the divergence of curl of a vector is a 0 using the Stokes theorem. We already know the cross product, cross and the dot, if it is the same the value, it is a 0 value. the divergence of curl function is always a 0. Del dot del cross A bar is equal to 0. So the curl of A bar is del cross A bar, and its divergence is del dot. Divergence means the dot product. Del dot del cross A bar. Now del cross A bar is a vector, while divergence of vector is a scalar. That is equal to alpha. We can consider. Apply the integration, the volume integral on both sides. The volume integral of del dot del cross A bar dV is equal to. Now, if I am taking this function as integral alpha into dV, both sides, applying the divergence theorem, the left hand side can be converted into the surface integral. The volume integral is converted to the surface integral means definitely we can write this function as del cross A bar. So since the alpha is equal to del dot E, del cross A bar means the surface integral is del cross A bar dot ds. Okay, del cross dot ds bar. Whenever if it is a volume integral is converted to the surface integral, del dot del cross A bar dv is equal to, or del dot d bar is equal to dv is equal to the function whatever we have here, that you can take as the del cross A bar dot ds. Once again, I will explain here. Applying the divergence theorem, the left hand side can be converted into the surface integral. Del dot d bar dv is equal to, you can convert it to the del dot d bar dot ds. Okay, my students. Actually, this is from the Gauss law of electric field. Q is equal to d bar dot ds. What is a Q is equal to? Q is equal to dq is equal to rho s into ds, or the rho b into dp. Let us take here the rho b into dp. dq is equal to q is equal to integral rho v into dv. So integral rho v dv is equal to integral d bar dot ds. The surface integral is converted to the volume integral, means del dot d bar into dv. So d bar, that is equal to del dot d bar is equal to rho v. This is one of the Maxwell's equation. Now, similar fashion here, it is a del dot instead of d. There is a del cross A bar. So the previously the d is replaced as a del cross A bar. It's a del cross A bar dot ds. Got it? The surface integral. So where the S is closed surface and closing the volume, that is in the alpha, totally this function is converted the volume surface integral del cross A bar dot ds bar is equal to the volume integral dv. Now if the Stokes theorem is applied, it can be seen that the surface on the left hand side of the equation 4 is enclosing with the volume and is not the open surface. The Stokes theorem applied, the closed surface produces the 0. Sorry. So integral volume integral alpha into dv is equal to 0. Whenever it is in the convert into the surface integral, that is a 0 value. Is to the differential volume is a 0. Alpha into dv is equal to 0. dv is not at all equal to the 0. Differential volume is not equal to 0. Alpha is equal to 0. Therefore, del dot del cross A bar is equal to 0. This proves that the divergence of curl of vector is always 0. The divergence and the curl, if anything, you'll get that value is always the 0. Got it, my students? The Stokes theorem applied to the closed surface produces the 0. Okay. Coming to the next example. Evaluate the both sides of the Stokes theorem. For the field h bar is given and rectangular path around the region x value, y value, and the z is equal to 0. Let the positive direction of ds be the az bar. According to the Stokes theorem, the h bar is given means h bar dot dl bar is equal to I amperes circuit law. Actually, h bar dot dl bar is equal to I. Now I am taking the Stokes theorem means line integral is converted to the surface integral. Line integral is converted to the surface integral means cross product. Volume integral is converted to the surface integral means dot product. Cross product del cross h bar dot ds bar is the equivalent of integral h bar dot dl bar. Now let us evaluate the left hand side. The integral h bar dot dl bar is equal to, when we considered the integral to evaluate the perimeter of closed path. You see, this is a closed path here, A, B, and the direction is here, the B to C, C to D, and the D to A. It is on the Z is equal to 0 plane. H bar dot dl bar is equal to integral AB, integral BC, integral CD, and integral dA h bar dot dl bar. Okay, integral AB h bar dot dl bar is equal to dl bar is equal to the x value. X value you can take x is equal to 2 to 5. Why I am taking the 2 to 5? They given the range of x is here 2, 5, and y is minus 1 to 1, and z is equal to 0. 2, 5 is x. So the point it is x is equal to 2, 5, and y is equal to minus 1 to 1, and it is at the z is equal to 0. So x is equal to 2 to 5. The given function of h bar is in the ax bar direction. If I am taking, since AB value is in the x direction only, dx into ax bar. Carefully observe, my dear students. It's the ax bar, dx into ax bar. So ay into ax bar is a 0. Second term gets a 0, and only you get the first term. 6xy into dx. 6xy into dx, that is ax bar dot ax bar is equal to 1. So 6y into x integral is x square by 2, upper limit is a 5, and lower limit is a 2. Substitute the value to get the 63y. Okay. And now at y is equal to 1 for the path of AB, the integral AB h bar dot dl bar is equal to minus 63. Okay, minus 63. Now coming to the integral BC. BC means this is a function. This is along the y direction. Along the y direction means h bar you can take it as a y function, minus 3y square. So minus 3y square ay bar dot dy into ay bar. So ay bar dot ay bar is a 1. So integral y is equal to minus 1 to 1 minus 3y square dy. So minus 3y cube by 3. Upper limit is 1 and the lower limit is a minus 1. So minus 3 into 1 by 3 minus 1 cube by 3. It becomes of minus 3 into 1 by 3. Minus 1 cube means is a plus will get here 1 by 3. Okay, and is multiplied here. There is no any multiplication, directly will get the value 2 by 3 into minus 3. So 3 get cancelled and we get the minus 5. Minus 2. There is no any value, that directly we got the minus 2. So for AB, for AB, A to B, we got the value is a minus 63, and B to C, the value we got the minus 2. Okay. Then after the C to D is the opposite direction of the x. The integral value is a h bar dot dl bar. The h bar is a x value only. You can take the 6xy ax bar dot dx into minus ax. minus AX bar. Okay. So the AX bar dot AX bar is equal to 1, and the 6y, we can take the x square by 2, or the by 2, okay, x square by 2. The upper limit is a 5 and 2 and 5. So minus 63y, and the value now I'm taking is a positive value. If it is a minus, you can already substitute it. It is a minus AX bar. Minus AX bar means you can substitute y is equal to minus 1. Then it becomes of the 63. So at y is equal to 1 for the path of CD, hence the CD is a h bar dot dl bar is equal to minus 63. Okay, my dear students, it's a 6 into y value is a 1 here. We can substitute the y value is a 1. 6 into 1 x cube 5, 2 and the 3. You can apply the 2, the 4 by 2 minus 25 by 2. It becomes of 6 by 2 is a 3 minus 21 is a minus 63. That's a value of minus 63, but we can substitute the value is a 1. And y is equal to 1, will you get the minus 63. Got it, my students? Then C to D8 is completed, is a minus 63. And D to A is a y direction. So you can take the minus 3y square ay bar dot dy into minus ay bar. So minus into minus is a plus, so y square dy, and 3y square is a y cube by 3, and 3 by 3 get cancelled. Y cube is a 1 and the minus 1. 1 cube minus of minus 1 cube. We'll get it is a 2. The h bar value. Okay, my dear students, plus 2. So minus of minus is a minus 1, and it is a minus 1, but minus into minus is a plus 2. So total the area is there. That one minus 63 minus 2 minus 63 and plus 2. Plus 2 minus 2 get cancelled. You get the minus 126. Okay. The value is integral h bar dot dl bar. See, h bar dot dl bar is the left hand side. Del cross h bar dot ds bar. Del cross h bar dot dl bar. Now del cross h bar dot dl bar is the Cartesian coordinate system. Ax coefficient is a 6xy and ay coefficient is a minus 3y. Apply the del cross is ax bar coefficient is from here is a 0, and the dou by dou z of this function is also the 0. Minus ay bar. Minus ay bar means again it is a 0, and here there is no any z term. This ay bar coefficient is also 0. Plus az bar coefficient is, what is the az bar coefficient? Dou by dou x of 3x square is a 0. Minus dou by dou y means you will get the 6x. So 6x, that is equal to minus 6x into az bar is the left hand side function. And apply the del cross h bar dot, not the dot, sorry, dot only, dot ds bar. It is in the az bar means you can take this also the az bar direction Cartesian coordinate system. It becomes the integral, the surface integral minus 6x into az bar dot dx dy az bar. Az bar dot az bar is equal to 1, and that integral it becomes of minus 6 dx dy. Okay. Minus 6 is take the common. X value you can varies from 5 to 2. 2 is a lower limit. and x into dx, and you get the minus 1 to 1 of the d1. So minus 6 into x square by 2, with upper limit is a 5 and a lower limit is a 2, we can take and then another integral, y integral is a 1 with the minus 1, minus of minus will become is a plus 2. So minus 6 into 2, 5 square 25 by 2 minus 4 by 2. The 2 to get cancelled here. Minus 6 into 21. That is equal to 126 of minus amperes. On both sides of the same, hence the Stokes theorem is verified. So what is the Stokes theorem saying here? Del cross h bar dot ds bar is equal to integral h dot dl bar. The line integral is converted into the surface integral. Okay. Coming to the next example. A cylindrical coordinate system, B bar is given, nothing but is a magnetic flux. Determine the magnetic flux phi crossing the plane surface by R is in the range of 0.5 to 2.5 and Z is varies from the 0 to 2. It's a cylindrical coordinate system. I want the gas law of magnetic field, phi is equal to integral B bar dot ds bar. B bar dot ds bar. So ds is a surface given that the 0.5 and the 2.5 is in the R. So see this is a point on the R axis. And the Z is also given. Z is equal to 0 to 2 meters. Okay. And this is a phi direction because it's a cylindrical coordinate system. Phi is a plane of x, z plane. Okay, till the xz plane, the 2 pi. So the ds bar is in the phi direction. You can move that it's the phi direction. The ds bar is equal to normal to the phi direction. The components are dr and the dz. B bar is given in the phi direction also. The phi is equal to integral B bar 2.0 by R into A phi bar dr dz A phi bar. So A phi bar dot A phi bar is equal to 1. So 2.0, the integral is 1 by R into dr dz. That is equal to 2 into the R. R is equal to varies from the 0.5 to the 2.5. And integral Z varies from the 0 to 2. 1 by R into dr. 1 by R means the integral value is ln of R. With the upper limit is 2.5. Lower limit is 0.5, the 2. And Z value is upper limit only will get as a 2. So 2 into 2 is a 4, ln of 2.5 by the 0.5. Okay, 4 into the function. The 2 and upper limit is a 2, the 2 into 2, the 4. ln of 2.5 minus ln of 0.5 is 2.5 by 5. You get the phi is equal. Determine the magnetic flux, phi. The crossing the plane surface defined the R is equal to and Z is equal to, we got the phi is equal to 6.4377 Weber's. Got it, my students? I want the gas law of magnetic field, phi is equal to B. B bar is in the phi direction, means you can check the surface integral is also in the phi direction. Okay. Next example. Find the flux passing the portion. Find the flux passing the portion of the plane phi is equal to pi by 4 defined by R is the range of 0.01, 0.05, and Z is the 0 to 2 meters. R is the range here. The value is 0.01 and the 0.05. And the Z is equal to 0 to 2 meters is a 5, the same example what we did in the previous video. But with an angle of 5, the tilted is already the tilted with the phi is equal to 45 degrees. The exact plane, already this exact plane, the tilted with an angle of 45 degrees. Find the flux passing through this position. Before that, we know the formula for the, due to the current carrying conductor in free space of the axis, H bar is given by I by 2 pi R into A phi. Means a long straight conductor, H bar due to a long straight conductor, we have the formula, the H bar is equal to I by the 2 pi R into A phi. What is the current given? Current filament is a 2.5 amperes. 2.5 amperes. It is 2.5 by the 2 pi R into A phi bar, and we can simplify this function. The 2.5 by the 2 pi will get the 0.39 by the R. But they are asking that is a flux passing. Flux means it is related to the B bar. This is a magnetic field. Magnetic flux is a B bar is equal to mu naught into H bar. What is a mu naught of 4 pi into 10 to the power of minus 7 into the given got the 0.3978 by the R into A phi bar. Simplify this function. The B bar we got as a 5 into 10 to the power of minus 7 by R into A phi bar. Okay, we got the B bar also. We need to find the flux by using the Gauss law. Phi is equal to B bar dot ds bar. Phi is equal to integral B bar dot ds bar. What is a B bar? It is in the phi direction. So phi direction means the 5 into 10 to the power of minus 7 by R into A phi bar. Okay. Dot ds bar also you can take in the phi direction as of dr dz into A phi bar. That is equal to integral of A phi bar dot is a value is a 1. So 5 into 10 to the power of minus 7 by R dr dz. So the value of 1 by R with dr is a ln of R. With upper limit is 0.05, the lower limit is 0.01, you can apply. And dz is a z integral, upper limit is a 2, lower limit is a 0, and the constant value is a 5 into 10 to the power of minus 7. Okay, 5 into 10 to the power of minus 7. Got it, my dear students? Simplify this function as 5 into 10 to the power of minus 7 means after taking the upper limit is of z is a 2, 10 into 10 to the power of minus 7 ln of 0.05 by 0.01. So take both are, it is a by 100. 10 into 10 power of minus 7 is 10 power minus 6 ln of 5. To simplify this function, we'll get 1.6094. ln of 5 is 1.6094 micro. 10 power minus 6 is a micro Webers. Got it, my dear students? The next example. So here also they given the cylindrical coordinate system. A bar is equal to 55 R square AZ bar Weber per meter is a vector magnetic potential in a certain region of free space. Find H bar magnetic field, B bar magnetic flux, J bar current density, and using J bar find the total current I also. Means you know the relation of J and the I is equal to integral J bar dot ds J bar dot ds bar, or I is equal to J into S. So B bar is equal to, according to that, the Laplace equation of the cosine equation, we use the B bar is equal to del cross A bar. Del dot del cross A bar, the divergence of curl function is always a 0 minus. Means in the Maxwell's equation, del dot B bar is equal to 0. This is one of the Maxwell's equation, the monomagnetic field. Del dot B bar, when we comparing these two functions, so B bar is equal to del cross A bar. Is already we proved that now in this class only, the del dot del cross A bar is equal to 1. Divergence of curl function is always a 0. This is one of the Maxwell's equation. Comparing these two, B bar is equal to del cross A bar. Since it is a cylindrical coordinate system, cross product of A is previously we did the example in the yesterday's class, 1 by R into dou AZ by dou A5 minus A5 using this formula. ER, it is a AZ bar coefficient only the given. So both the AR and A5 is a 0. AR and A5, whatever the AR is a 0 and A5 is also 0 and AR is also 0. The last term is get cancelled because AR and A5 is a 0 here. And A5, this function is also 0. Only the two terms will get 1 by R into dou by AZ. What is the AZ coefficient here? The 50 R square. And it is with respect to the phi, this value is also the 0. With respect to the phi, this term is also the 0 minus. There is no any AR bar coefficient also. And only the one term, because the AZ with respect to the phi, here the R only. And here the dou by dou R of AZ. Dou by dou R of AZ means AZ coefficient is a 50 R square with respect to the R, 50 into. So B bar is equal to having only the one term finally is a minus dou by dou R of AZ, that is a 50 R square AZ bar. Okay, 50 into 2R, that is a 100 R minus into A 5 bar minus, it's not the Z, A 5 bar. A 5 bar. B bar is equal to minus 100 R A 5 bar Weber per meter square is a magnetic flux. They are asking that is a H bar also. What is the relation between H bar and B bar? H bar is equal to B bar by the mu naught. B bar minus 100 R A 5 bar, mu naught is a 4 pi into 10 power minus 7. Okay, just substitute that one, you get H bar also. Calculate the H bar by substituting the mu r, or otherwise leave it like this. And they're asking J bar also. They got another Maxwell's equation saying del cross H bar is equal to J bar. Okay, del cross H bar is equal to J bar. And in this H bar, only we have the term is there, the A5 bar only. A5 bar means H5 only. HZ and HR is the zeros. H5 and the HR is the zeros minus. So again, del cross H bar using this formula only. Del cross A is here. Now here the del cross H. Del cross H bar. H5 the term only. H5 term is dou by dou Z of this one and the phi. The remaining all the terms is the zeros. Dou by dou Z. In the first term also, when with respect to the dou by dou Z, there is only Z term. The bell becomes a 0 here, and the second term is also 0. And dou by dou R means del cross H bar is equal to, as that is a J bar, 1 by R into dou by dou R of this function. So minus 100 by mu naught is a constant. with respect to the R means 2R into AZ bar. So R get cancelled. So J bar is equal to, we got as minus 200 by mu naught AZ bar. That is a J bar is equal. And using this J bar, you can find the current also. What is the current here? I is equal to J bar dot ds bar. The formula I is equal to J bar dot ds bar. What is the J bar? It is in along the Z direction. You can take a minus 200 by the mu naught into AZ bar. The surface integral also you can take in the AZ bar direction. Only the R into dr d phi AZ bar. So minus 200 by the mu naught is a constant. AZ bar dot AZ bar is equal to 1. And another here the integral is R into dr and the integral is a d phi. Minus 200 by the mu naught R into dr is R square by 2. With R is given of upper limit is 1 and the lower limit is 0. And the d phi upper limit is 2 pi and lower limit is 0. So minus 200 by the mu naught R square is 1 by 2 and the 2 pi. So 2 get cancelled and finally the current is equal to minus 200 pi by mu naught. 200 pi by the mu naught. Got it, my students? The current also we got minus 200 mu naught. Substitute that mu naught value also. That is a 4 pi into 10 power minus 7. So current I is equal to, what is the finally we got the 200 into pi by the mu naught. What is the mu naught here? Minus 200 pi. Mu naught is a 4 pi into 10 to the power of minus 7. So pi get cancelled and force is a 50. So 50 by 10 power minus means you get the 10 power 7 in the numerator. So 110 we can take here. 500 is a minus is L minus students minus 10 power 6 amperes. The current I is equal to minus 500 10 power 6 amperes. Got it, my dear students?